Hello everyone, welcome you all to the next lecture of the JC eConnect series of online lectures. We have started with module 5 and we are dealing with the topic Anchorage zone stresses in post-tensioned members. So this is the same visual as we have seen in the previous video, that is the Indian code provision. So today we will be discussing briefly about the formulas and the applications which we will be requiring to solve the examples. From the next lecture onwards, we will go ahead with the examples. So as per the Indian Standard Code, that is IS 1343, it is based on the work of Zelsinki and Rowe. We get the formula for obtaining the bursting stress or bursting tensile force as if BST is equal to PK into bracket 0.32 minus 0.3 divided by multiplied by y p naught divided by y naught, where pk is the jacking force or the precessing force and yp naught divided by y naught is the distribution ratio. Here yp naught is equal to the side of the loaded area and y naught is equal to side of the end block. Now these things, that is about the distribution ratio and all, we will be discussing in this today's lecture. So again, as per the code book, the bearing stress should not exceed 0.48 FCK into square root of ABR upon APUN, that is punching area, or 0.8 times of FCK, whichever is smaller, where FCK is the cube strength of concrete, ABT is the bearing area and APUN is the punching area. So here we have to take care that the bearing stress in any case should not exceed the least of these two values. This becomes a very important clause in the IS code which we need to strictly follow while designing for the anchorage block. Now next comes the most important concept, that is the prism. Okay, the loading prism and the surrounding prism. So now when we look at this figure carefully, it's a cut section of a beam in which we are able to see the width of the beam and the depth of the beam. So here we get an prism. Okay, now this hatched portion which is marked here in the figure, we term it as an surrounding prism, which we call it as the bearing area, or this is the area over which the bearing plate is attached, through which the pre-stressing force is applied to the beam section. So this area becomes very important for us during analysis. So 2y0 is this total depth or total width of the section. 2y0 is the least of breadth of the beam B or depth of the beam. So while analyzing an example, the value of 2y0 will be the least of either B or D, which is the depth of the beam. The next 2yp0 into 2yp0 will be the size of the anchor plate or the bearing plate. This will be the area through which the pressure will be applied. So y0 and yp0 are the very important terms which we need to understand while solving the examples. Then about reinforcement. So the area of the reinforcement required is obtained as A required is equal to F BST, that is the bursting force which we obtain from the equation given by the IS code, divided by 0.87 times of Fy. Then the number of reinforcement bars to be provided is calculated using the relationship area required divided by area of 1 bar. This is the same way as we used to find the reinforcement in case of RCC, AST required upon the area of diameter. In similar way here we have to calculate the number of bars required for providing in the end block or the anchor zone. The reinforcement provided is in the range of 0.2 y0 up to 2 y0. So we start the reinforcement from 0.2 y0 distance and we provide that end block reinforcement up to a span of 2 y0, because the maximum stress distribution and variation occurs in this particular range of 0.2 y0 up to 2 y0. Hence, we provide our anchor reinforcement or anchorage zone reinforcement in this particular area. Then the next thing which we have to learn here is, if we get a circular plate through which the anchorage is done, our calculations are based on assumption that the bearing area is square in shape, okay. But if our system is providing a circular jacking end, then this area of the circle has to be converted into an equivalent area of a square, okay. So many times we get such problems in the exam where the diameter of the bearing plate or the anchor plate is given, and for analysis we have to assume it to be a square and convert the area of the circular plate into an equivalent area of the square plate and get the side of the square. This can be done as follows. So in case of a circular anchor plate, we need to find the side of an equivalent square plate, that is, area of a circle is equal to area of the equivalent square. Area of a circle is pi into d square by 4, which we equate to the area of an equivalent square. So let us assume that the side of the square is A. Therefore, area of the square will be A into A. Therefore, pi d square by 4 is equal to A square. Hence, taking square root, we get A is equal to square root of pi into d square by 4. Okay. So this is the equivalent side of an circular arrangement which we assume for the analysis. Then what will be this A? This A will be nothing but 2p y0, as we saw in the previous figure, that is the length of the bearing plate. So we get the length of the bearing plate as the side of the square, which is equal to square root of pi into d square divided by 4. So this is the equivalent side when a circular arrangement is provided for post tensioning. Okay. So in many examples we will be using this relationship. So in examples, if I use this directly, don't worry from where it has come. Please note down these formulas and be ready to solve the examples. Okay. So mainly in these examples are straightforward and easy. We need to compute the bursting force. Once we compute the bursting force, using that bursting force, we need to obtain the area of reinforcement required. From the area of reinforcement required, fixing a suitable diameter of the bar, we need to find the number of bars required or the spacing required. Okay. So these examples are straightforward. So be prepared with these formulas. From the next lecture onwards, we will go ahead with the examples. And as your internals are postponed, this part of the syllabus also may be included for the internals. Okay. So start preparing it as we are releasing the videos. Thank you.